Okay, so we're going to talk about how to graph the sine function, how to graph the cosine function. The first definition that we want is what does it mean to be periodic? A function is periodic if f of t plus p equals f of t for all t, where p is some period. Okay, so we'll understand what this means as we go through graphing the sine function. So the sine function is a function, and we're going to look at graphing it by looking at, first of all, t values. Suppose I have a string of length 0, right? So I'm starting at the point 1, 0, and I've got a string of length 0. Well, that means the terminal point right there is the point 1, 0. Well, we know that sine of t equals the y-coordinate, okay, that corresponds to this terminal point. So when t is 0, sine of 0 then, so sine of 0 would then be the y-coordinate here. What's the y-coordinate here? Well, it's 0. Very good. Good. So what happens as we increase t? Well, suppose I go from t equals 0 to t equals, say, pi over 4. Well, I go to pi over 4. So here's pi over 4 right here. So this is t equals pi over 4. That was t equals 0. So now we've got the terminal point, root 2 over 2, comma, root 2 over 2. Okay? So sine of t is the y value. What's the y value here? Root 2 over 2. Okay? Fantastic. Now root 2 over 2 is, 1 point something divided by 2. It's a little bit more than a half. What happens if I go to pi over 2 though? So now I'm going from t equals 0, then t equals pi over 4. Now I'm going to go t equals pi over 2. So this is the terminal point 0, comma 1. This is t equals pi over 2. Well, what's the y-coordinate there? Well, it's 1. So if I graph these points, right? So I have, here's on a t y-axis, okay? So in this case, in this case we have, we want to graph the function f of t equals sine of t. Well, we have the point 0, 0. That's one of the points. Then we have the point, here's say pi, and here's 2 pi. Here's pi over 2, 3 pi over 2. Pi over 4, I get a little more than a half, so I'm up here somewhere, right? Root 2 over 2 divided by 2. And then I have a pi over 2. This is pi, that's pi over 2. A pi over 2, I have the height 1. Okay? So as t went from 0 to pi over 2, the graph of sine of t looks kind of like this arc. So as t went from 0 to pi over 2, I went from 0 to a height of 1. Okay? So sine of t went from 0 to 1, right? All right, what happens from pi over 2 to pi? Well, as we look at it, we could put 3 pi over 4 here, and we'll note that our height is root 2 over 2, right? If we go 3 pi over 4, that puts me right here. We know our height is root 2 over 2. Okay, that puts me going down this way, right? So if I get to pi, what happens then? Well, if I get to pi, t equals pi. We go from there to right there. What's my height? Well, my height is 0. Okay? So as t went from pi over 2 to pi, from pi over 2 to pi, what happened to the height of this thing? It went from 1 all the way to 0. Okay? Good. Now what happens when I go from, I'm going to continue this, I'm going to put it right here, t sine of t. What happens when I go from pi to 3 pi over 2? So now I'm going from, this was pi, I'm going to pi over 2. Well, what's the terminal point here? Again, the terminal point here is the point 0, negative 1. Okay, so I'm going straight to 3 pi over 2 this time. And we know that sine of 3 pi over 2 is negative 1. And it's going to look very similar. We're going to get to that, negative root 2 over 2, and then we're going to get to right there, -1. So we went from pi to 3 pi over 2. Sine of t went from 0 to -1. And then as we go from, say we go back to 2 pi, 2 pi, what's the terminal point if t is 2 pi? 2 pi is back here. What's my terminal point? 1, 0. What's the height? The y value? 0. Okay. Then I get a height of 0. And then what happens is I start repeating that process. So I went from -1 to 0. So what happens is I'm going to repeat that because what happens now? I'm at 0 here, right? The terminal point 0, and I went 2 pi. If I go from, say, 0 to 5 pi over 2. 5 pi over 2 is, 2 pi plus a half pi. Then I'm going to go from the height of 0 back to the height of 1. And so what's going to happen is I'm going to start duplicating this all over again. And similarly, we're going to duplicate this all over here. And that's why we say sine is periodic. Sine is periodic in the sense that I've got the same function over and over in a given period, right? Control C, Control V, and both sides, okay? It's going to continue on that forever, okay? Now let's take a look at cosine. So now we're going to talk about cosine function and how it looks in its graph. So we're going to do the same type of techniques that we use with sine, but now we're going to look at it from the cosine perspective. So again, we're talking about t-values, and if I have a t-value of 0, okay, so I have a rope, if you will, of length 0, my terminal point corresponding to that is the point 1, 0. So cosine, we recall, cosine of t is equal to the x value of the terminal point, okay? So in this case, my terminal point here is, for my x value, is 1. So when t equals 0, cosine of t equals 1, okay? And what we're going to do is we're going to graph that point. So we have 0, 1, 0, 1. There's the point on this graph, okay? So we put in here, we put in a t value, and we put in what cosine of t is, all right? All right, so then we're going to move on. Suppose I move on and I look at as t grows from t equals 0 to, say, t equals pi over 2. So let's go to pi over 2. And when t equals pi over 2, we get a value of 0. And so you'll note that as t goes from 0 to pi over 2, cosine goes from 1 to 0. So here I'm going to go from 1 to 0. Okay? And then as t grows from pi over 2 to, say, pi, we know that cosine of pi is -1. So as t goes from pi over 2 to pi, we go from 0 to -1. So here I'm going to put 0 to -1. So now I go from, I have cosine of, again, I have pi, 2 pi, pi over 2, 3 pi over 2. And as we went from 0 to pi over 2, we go from the height of 1 to a height of 0, right? Good. And then as we go from pi over 2 to pi over 2 is here. As pi, we go from 0 to -1. Okay. And then continue. Let's go to 3 pi over 2. 3 pi over 2, as it grows from pi to 3 pi over 2, my height, or my x value, excuse me, my x value goes from -1, okay, to 0. So now I have a height of 0. So here I'm going from -1, 0. Here's my height of -1, and it goes to 0. And then again, when I go to 3 pi over 2, excuse me, when I go from 3 pi over 2 to 2 pi, so here it goes to 2 pi. What's my x-coordinate? My x-coordinate is back to 1. So it goes from 0 to 1. So I go from the height of 0 to 1. And then I have my cosine function. Okay, this is the graph of the cosine function in the period 0 to 2 pi. Okay, in that area 0 to 2 pi. Note that if I looked at it from, say, 2 pi to 4 pi, it would have the exact same look that it has right now. Or if I looked at it from negative 2 pi to 0, it would have the exact same look. Okay? Again, Control C, Control V, Control V, and so forth. It's periodic. Okay? Every 2 pi, it repeats. Okay? Notice that both in the sine function and the cosine function, the maximum height of both of them is always 1. They never get bigger than 1. The lowest that they ever get is negative 1. Okay? They never go above or beyond that, right? For any value of t. Now we're going to graph transformations of sine and cosine functions. Transformations just mean we take a base function and transform it. So the base function, this first one, if I want to graph y equals 2 sine x, the base function is sine x. Well, we know what sine x looks like, and we only have to graph it in one period, because if we have one period, well, we've got all the other ones. We just copy and paste it. So I'm first going to start off with just pretending, hey, I want to graph sine x first. What is sine x? Not 2 plus sine x, just regular sine x. Well, sine of x looks something like this, correct? Okay, with maximum height of 1, and as low as it gets is negative 1. Very good. So what is 2 plus it means? Well, if I had, say, x value and then sine x and then 2 plus sine x, what does that do here? Well, if I put in values, I know if I put in 0 for x, yeah, that's fine. If I put in 0 for x, it could be t, it doesn't matter. If I put in 0 for x, I'll get 0 for sine of 0. Now, but if I go 2 plus sine of x, where x is 0, don't I get 2? So the difference between these guys, and I'll go ahead and use a different color for this one. This is going to be like, say, 2 plus sine x, where it's in green. So the shift of 2 plus sine x takes this point and bumps it up 2 units, doesn't it? And you can similarly see it if I do pi over 2. Pi over 2, I know that if I put in pi over 2 for x, sine of pi over 2 is the y coordinate when we have a t value or a length along the unit circle of pi over 2, I get 1. But if I add 2 to that, note that I get 3. So when I go pi over 2, my function looks like 3. And so you'll notice what's happening here is it's looking something like that. And if I put in pi, right, if I put in pi, of course I get 0, that's the height. But if I put in, add 2 to it, I get 2. So what's happening here? Notice what's happening. It's taking this sine function and shifting it up 2 units. And so if you continue on that, you'll kind of see that it looks like this. And you can formally put those values in. If we put in, say, 3 pi over 2, and then 2 pi, if we put 3 pi over 2, we get negative 1, and if we put in 2 pi in my blue function, I get 0. But if I add 2 to both of those, I'm going to get 1 and 2 right there, and you'll see that that's my graph. 0, comma 2, pi over 2, comma 3, right? Pi, comma 2, okay? And 3 pi, pi, comma 2, right there. 3 pi, 3 pi over 2, comma 1, 3 pi over 2, comma 1, and 2 pi over, and then 2. So really, if I add a number to a given function, that shifts it, and that if I add a positive number, that shifts it up. If I add a negative number, guess what that does? It shifts it down. So if I wanted to graph, say, just for fun, suppose, and we'll do this in another color here. Well, I don't have another color, so we'll have to do it in green again. Suppose I wanted to graph, say, instead of 2 plus sine x, suppose I wanted to graph the function negative 3 plus sine x. Well, that would take this blue graph, that's the base function, the blue graph, and shift it down 3 units. So the whole thing down 3 units. And so it'll look something like that. Okay, good. So this is a vertical shift. If I put a number out, I'm shifting it vertically left or up or down. Excuse me. Okay. Positive makes it shift up, negative makes